Welcome everyone. This is the first lesson recording for December 3rd, 2020. What are we doing today? We are going to be multiplying polynomials. We're going to do a whole lot of practices there. We're going to start off with some monomials with monomial. That's one term with one term polynomial. Then monomials with polynomials. That's multiplying one term polynomial with many term polynomials. And then finally binomials with binomials. The binomials, if you recall, are two-term polynomials with another two-term polynomials. So let's just quickly review what we said last lesson. So if you are multiplying 3x squared y with 4x y squared, by the way, 3x squared y is a monomial because it has one term, and we're multiplying that to another one-term polynomial. So it's a monomial multiplying to monomial. So in this case, 3x squared times y is really 3 times x times x times y. And then to that, we are multiplying 4xy squared, which is 4 times x times y times y. Okay, that's what each of the term represents. When there is just number and variable, there's a invisible, the default multiplication sign right there. And then between x and y, again, there is an invisible multiplication sign right there. And y squared really just means y is being multiplied to itself twice. So that's what you get. Then we're basically multiplying from left to right. However, since multiplication is commutative, we can bring the numbers together and all the variables together. So if you do that, rearrange this, we can bring the 4 to the front to be multiplied with the 3 and bring all the x's together and bring all the y's together, which simplifies to 3 times 4, which is 12. X times x times x is just x to the power of 3. Y times y times y is just y to the power of 3. So we don't even need those dots, that multiplication dots. We can just remove that. The final answer is going to be 12 x to the power of 3, y to the power of 3. Another example we covered was negative xy multiplied by 4xy. Remember, when you see a parenthesis, this is just another notation for multiplication. Just like the multiplication dot, this is just another notation. This time, whenever you see a negative sign, I want you to start thinking of it as -1 is being multiplied to x and y. Whatever it is following, -1 is being multiplied to it. So negative xy is really -1 times x times y. And 4xy, of course, is 4 times x times y. So you're multiplying both of them together. So bring all the numbers together, -1 times 4. Bring all the x's together, x and x. And bring all the y's together, y and y. And you're left with -4 multiplied by x times x is x squared, y times y is y squared, which finally simplifies to -4x squared y squared. So at this point, I would like you to try to go through the Desmos activity from card number 1 to 4. You will find the link from Canvas. Okay, we are starting really easy here. So we are multiplying x to the power of 3 multiplied by x to the power of 4. The reason we are doing this is just to make sure that you are fully aware or very clear on the exponent rule. This is same as x times x times x. That's the x to the power of 3. And then to that, you are multiplying x times x times x times x, which means that x is being multiplied to itself 7 times. So this simplifies to x to the power of 7. Now, if you recall, when the bases are the same and when you're multiplying the exponents, you just need to simply add. And that's the reason this occurs. It's just, you just need to be adding 3 plus 4 is 7 here. So when you're multiplying the exponents, when the bases are the same, then you just need to add the exponents. Okay, this time x to the power of 3 times 5x to the power of 8. This is same as when there is no number there, the default is number 1. Oops. So it's number 1. I can even put number 1 there. So it's going to be 1 times 5, which is 5. X to the power of 3 times x to the power of 8. So we have x to the power of 3 multiplied by x to the power of 8. Okay, so that means x is being multiplied 3 times here, and then x is being multiplied 8 more times here. So we can just add the exponents, and we say that the final answer will be x to the power of 11. Okay, how about this one? We have 5 times negative 3, that's going to be negative 15. And then we have x to the power of 4 multiplied by x to the power of 2. So x is being multiplied to itself 4 times, and then 2 more times. That means it's going to be x is going to be multiplied to itself 6 times altogether. All right, then finally multiply the monomial by monomial. Simplify. Okay, this time 4 times negative 2 is going to be negative 8. And x times x to the power of 6. X to the power of 6, x is being multiplied 6 times, and then one more. So that's just going to be simply x to the power of 7. Now, if you recall from the last lesson, the distributive property simply just states that when you have some number multiplied in parentheses to b plus c, then the result will be same as a times b plus a times c. Or visually, you can see this as if you have 3 rows of 5 blocks, then you can separate the 5 blocks as 2 and 3. So this can be 3 rows of 2 plus 3, 2 blue and 3 blue blocks can be written as 3 rows of 2 and 3 rows of 3. So that means we can rewrite this as 3 times 2 plus 3 is same as 3 times 2 plus 3 times 3. So why do we care about that? Well, we know that it works from the previous example. However, when we see problems like this, where we cannot simplify what's inside the parenthesis first, this property comes really handy. So in this case, when you have 4x multiplied by 3x plus 2y, inside the parenthesis, because 3x and 2y, they're not like terms, so we cannot combine those. So the only thing we can do is, since 4x being multiplied to what's inside the parenthesis, we can multiply the 4x to each of the term inside the parenthesis. So in this case, this is going to be 4x is being multiplied to the 3x first, and then to that you're going to add 4x being multiplied to the second term. So you can visualize this as 4x times 3x and 4x times 2y. And the final answer is going to be 12x squared plus 8xy. And if you recall from last year, you learned the area model. You did do this multiplying in last year, where you use the area model and where you are multiplying 4x. That would be one of the length of the rectangle, and then 3x plus 2y, that's going to be the other width of the rectangle. So we call this the area model. And to find the area of this, the total area 4x times 3x plus 2y, you're basically multiplying the length by width. is going to be same as 4x times 3x. So you multiply that separately. And to that, you're going to add 4x multiplied by 2y. And you get the same answer. Okay, so you've done this using the area model last year. Let's just quickly show another example. 3m squared multiplied by 2m cubed minus m minus 1. You're basically multiplying 3m squared, whatever is in front of the parenthesis. It's not just the very last variable or the exponent. It's the whole thing is being multiplied. So it's 3m squared multiplied to the first term in the trinomial. And then to that, you're adding the 3m squared multiply the second term in the trinomial, which is negative m. And then to that, you're adding 3m squared multiplied by the third term, which is negative 1. And then, which simplifies when you multiply each of the terms, you get 6m to the power of 5 plus negative 3m cubed plus minus 3m squared. But we don't really need to write this plus or minus. We can just rewrite this as minus because adding its negative is same as subtracting. So it becomes 6m to the power of 5 minus 3m cubed minus 3m squared. And you did just like last year, we can represent this as an area model where you are multiplying 3m squared to 2m cubed minus m minus 1. So this will be basically you multiply the first length to the first term in or first part of the length, that's 2m cubed, and you get 6m to the power of 5, and 3m squared multiplied by negative m, and you get negative 3m cubed, and then 3m squared multiplied by negative 1, you get negative 3m squared. All right, so at this point, you are going to be working on card number 5 to 11, where you're using the distributive property. Okay, so this is the fifth card. This is just quickly explains. I did share last lesson that by convention, we always write the polynomials in descending order. That means the highest degree first, followed by the second highest, and then third highest, and then lastly, the constant is always going to come at the end. That's called standard form. Okay, it just makes communicating a whole lot easier, and it makes identifying the same or similar polynomials really easy that way. So please read this card. Okay, and then find the product. Find the product. So 6x multiplied by x plus 1. Okay, what is the answer? 6x times x. Again, what we're going to do is we're going to multiply 2x times x, which is going to be 2x squared. And then to that, you're going to add 2x multiplied by the second term, second term of the second binomial. The binomial. So 2x times 1 is 2x. So that's my final answer. What is the property that we use? It's distributive property. Okay. All right. So then let's move on to the next card. All right. Again, we are multiplying. So we're multiplying each of the term inside the parentheses. So 7 times 5 is 35. X cubed multiplied by x is x to the power of 4. 7 times 3, but actually we are multiplying 7 times negative 3. That's going to be negative 21. And to that we're multiplying x to the power of 3. And again, we're using distributive property. And please continue to the card 11. And the Desmos activity should give you the feedback as to whether you're doing it correctly or not as well.